You found the skeleton. How would you calculate that? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Welcome back, everybody, for part 2 of my series on Dan Biddle's takedown of the so-called 10 Pillars of Evolution. I'm the Dapper Dinosaur, and we're jumping back into Dan's introduction. Apparently, no one ever told him that your introduction shouldn't be the longest part of your presentation, but oh well. Without further ado, take it away, Dan.
These things, all these things, what do they have in common? Things like children's books, dinosaur shows, public camp retreats, college professors, peers, family members, nature trails, state parks, museums, public school, television, and movies. In fact, I someday try to see if I can just go a day without seeing Millions of Years somewhere. You turn on the History Channel, it's there, Nova, you go watch movies today. The kids are being steeped in this idea of millions of years. But the Bible presents a much different history because who existed before Adam? Nobody. There was no population of apes that God plucked and said, well, this ape looks cute. I think I'll turn him into a human. It did not happen. We have the family of Adam from Genesis 5, and we know that Adam lived 130 years.
And so on and so forth. But this isn't evidence, it's the claim. A book says X isn't evidence for the claim, but if the book provides references, then the references might be evidence if they are reliable. Unfortunately, the Bible doesn't really have a reference section, so all its claims have to be checked externally. Now, some of them have turned out to be true, like there really does seem to have been a King David, and Pontius Pilate was a real guy too. Some of them haven't been verified or disconfirmed, like whether or not a guy named Ezekiel ever had a fire starting contest. And some, like special creation, have been shown to be false.
And the flood. So either this is inspired scripture and it happened, or it's not, because it's written like a history book.
It's not, though, because history books didn't really exist when it was written. At the time, instead, what we had were polemics using the past, whether the true past or not, to make claims. Often these were political claims, such as that King so-and-so of Akkad was the greatest ruler of all time and the chosen of the gods, or that the current dynasty of Egypt was eternal. But in the case of Genesis, the point was religious. It was to show that the God of the Hebrews was supreme over the world, the sole creator, and was more powerful than the pretender gods worshipped in Mesopotamia. It was also a myth to tell the Hebrews where they and other nations came from, and how they related to each other, and how the Hebrews should act towards both the natural world, that is, that they should be stewards of it, and towards other nations.
The first 11 chapters of Genesis have the birth years, lifespans, or death of 37 patriarchs. That's not allegory, it's not poetry, it's talking about real history. Here we line it all up. We spent about 5 minutes last night talking about the fact that these pre-flood patriarchs lived an average of 912 years.
Except that genealogies were often used in the ancient Near East as allegory. The numbers were often exaggerated and used more for numerology than for a sober historical account. This continues even into the New Testament, where Jesus' genealogy is given in multiples of 7, because in Jewish tradition, that number is numerologically significant.
Then they hit the flood, then their lifespans began systematically and exponentially declining, getting shorter and shorter lifespans. And that was all because there was a genetic bottleneck when you take only 8 people from this population of the human genome that had probably millions of people before the flood. You take it down to just 8, put all those 8 people on the ark.
The Bible starts with a bottleneck not of 8, but of 2. Further, the ark bottleneck is actually a bottleneck of 5, since 3 of the 8 people are brothers and all the sons of the same couple. This really isn't a scenario where the genetics work out for a literal interpretation of Genesis 1 through 11 being historical.
And their mutations due to inbreeding start exponentially increasing and people start living shorter and shorter lives. There's lots of science to support that.
No, there's not, because inbreeding doesn't cause mutations. It causes increased homozygosity. So let's talk about homozygosity versus heterozygosity. A gene is a distinct sequence of nucleotides forming part of a chromosome, the order of which determines the order of monomers in a polypeptide which a cell, or virus, may synthesize. Genes exist at loci, singular locus, which simply means a particular location on a particular chromosome. Now, 2 organisms may possess the same gene, but have different variations of it. These variations are called alleles. So it is not technically correct to say that you could have a blonde gene and someone else a brunette gene. If we simplify hair color down to a single gene for the purposes of illustration, you would be more correct to say that you have a blonde allele and someone else has a brunette allele, but you both have a hair color gene. Now we have to come to ploidy. Ploidy describes how many copies of the genome you have in your cells. Humans are diploid, meaning that they have 2 copies of their genome, one from the father and one from the mother. This is slightly modified in the case of the Y chromosome, which is not a full copy of the X chromosome, so if an egg is fertilized without an X chromosome, which can happen due to errors in the production of sperm and eggs, the resulting embryo is not viable, because many X-linked genes are vital. But other than this minor caveat, humans have 2 sets of 23 chromosomes each. Each chromosome can have the same or different alleles at any given locus. When each chromosome has the same allele, the individual is said to be homozygous for that allele. When the alleles on each chromosome are different, they are said to be heterozygous. Now, inbreeding occurs when mating happens in a small or genetically similar population, resulting in alleles falling out of the population due to genetic drift, and an increase in homozygosity at most loci in the genome within that population. But here's the problem. This doesn't cause an increased mutation rate, but if it did, then we wouldn't see inbreeding. You see, most English speakers connect inbreeding with incest, or mating within the family. But that's not actually what inbreeding is in the scientific sense. Inbreeding is about genetic diversity, not the family tree of a mating pair. If you have high mutation, you don't have inbreeding, because formerly homozygous loci will in the descendants once again become heterozygous. So Dan here is arguing from both sides of his mouth. Either the supposed decrease in lifespan is due to harmful alleles fixing due to inbreeding, or it's because of dangerous new mutations. But it can't be both, because they are opposite effects. Of course, it could also be, and in fact is, the case that these stories aren't actually literally true.
So, but where does the world get this idea of millions of years from? Well, they get it from radiometric dating.
Well, not entirely. We knew that the world was at least several million years old before we could confirm that by radiometric dating. What geologists and physicists noticed was that first, some rocks simply couldn't be the result of rapid deposition, and we had thick and extensive deposits of such rock. And we also had features like unconformities in paleolandscapes, all of which require time to form, and in some cases, a lot of it. Also, we knew that the Earth was hot, and eventually that it also produced heat from radiation. This told us that it must have taken some considerable time to cool to the point where it was habitable. Only later did radiometric dating come and give some hard numbers that we could hang our hats on.
You can take radioactive materials like uranium and see it decay into lead, or potassium into argon, and you take the parent isotope and see how fast it decays in today's atmosphere into a daughter isotope.
Real quick, nuclear decay is, as the name implies, a nuclear process. It occurs in the nuclei of atoms. Atomic nuclei are essentially incapable of interacting via chemistry and pressure. And unsurprisingly, it's basically impossible to vary the decay rate no matter the external conditions. There are a few exceptions, such as the ability to sustain fission given neutrons, which can be thermalized by certain substances, which is how humans manage to get their reactors going. But for basically all purposes except fission in a small number of isotopes of a few elements, nuclear decay is not something that can be changed by external factors.
But there's 4 assumptions that we can't go back and see and test or observe or repeat like real science would require to prove that this is good science, because it works today. It works really reliable and consistently. You'll get the same ratios or similar ratios when you look at these decay rates in a laboratory today.
Yep, and since we don't observe physics changing today, we assume it didn't change in the past. And further, since we can see distant starlight that came to us from a long time ago, we can check some aspects of physics, and as far as we can tell, they haven't changed in the past. So unless we're given extremely good reason to think that these decay rates even can vary significantly, we should not think that they can, as we have excellent reasons why they shouldn't be able to. And reasons to conclude that in fact, they have not.
But we don't know the starting amount of the parent isotope because we weren't there supposedly millions of years ago.
In fact, in many cases, we do know the starting amount of the parent isotope, at least within a margin of error. And this is because in many cases, the parent isotope is the one which is included chemically as an impurity in the crystals forming in what is to become igneous rock. But the daughter isotopes cannot form impurities in the original rock in the same way, because being different elements, they have different chemistry which would exclude them. Now, this isn't the case for every kind of radiometrically significant isotope. but we also have techniques to cross-check dates and check for contamination or leakage. For example, an isochron date is achieved by using several radiometric parent and daughter isotopes and checking their ratios on a plot. If the plot deviates too much from linear, we know that there is contamination or leakage from the rock, and it also happens to have the advantage of cancelling out the amount of parent isotope in the equations, so the actual original proportion doesn't matter. It's almost like scientists have thought about these assumptions and come up with ways to check them, or cancel them out, so that they're not problems. But nah, experts never bother trying to make their measurement techniques reliable.
We don't know the starting amount of the daughter isotope.
Everything I just said about parent isotopes works just as well for daughter isotopes.
We don't know the decay rate is the same back then as it was today.
As I've stated, changing the decay rate essentially means you have to change the constants that underlie all of nuclear physics. You have to break reality to make these vary by any significant degree. So, given that it's creationists who are suggesting that maybe physics doesn't work at all, I would suggest it's also on them to demonstrate that physics just kind of broke down a few thousand years ago. And as far as the rest of the world is concerned, we should carry on with physics as is, and to therefore conclude that yes, decay rates were the same in the past.
And we also don't know if the whole thing is in a closed system.
As I've said, we can tell with isochron dating, and most of the things like metamorphosis, which would make parent or daughter isotopes leach in or out of a rock, are things we can detect simply by studying the rocks in question. One group of people I don't need radiometric dating to appreciate are my channel members and patrons. So let's take a moment before we continue to thank them now. I just want to take a second to thank my channel members and patrons, especially those pledging $20 and above. Bob Knob, Benthoven, Ian Chen, Chris Love, Sphincter of Doom, The Venerable Bede, Patrick Dennis, and Res Instance. My channel members and patrons help make this channel possible, and without their support, this channel really wouldn't exist. If you would like to help support the channel as a member or patron, there are links in the description to both join the channel as well as join the Patreon. Patrons and members get mentioned in these credit scenes, as well as getting early access to my scripted videos, and if you pledge $10 or above, you can also get access to various 3D assets that I create for Blender, both for use in the channel, as well as just general giveaways to my supporters to help in any Blender projects they might have. If a monthly or annual pledge isn't for you, then there is also a merch store linked in the description, and if none of that's right for you, please just like and subscribe because every like and subscription really helps the video out. Thank you.
Which it would be required to be in a closed system for it to be repeatable and reliable for back in the distant past.
Here, Dan finally got something right.
So all kinds of assumptions go in to radiometric dating. So let's test their assumptions to see how well they work. This is Mount St. Helens up in Washington. Was anyone around when this thing blew its top? I was a teenager. The sky was dark for 3 days. It was filled with ash. It was an amazing experience to live through. So there's what it looks like when it blows its top. It spewed forth ash covering 3 or 4 western states.
Holy crap, this dude needs to get to a point and fast.
But that provided a great opportunity because you know what? We could then go back to the dacite rock that was birthed out of the lava dome that people watched and got to see form in the 1980s, grab that rock, take it into a laboratory, and test how old it is. We can test radiometric dating in real time, and if it was a 10-year-old rock, it should come back in a lab saying it's a 10-year-old rock.
Not really, it should come back with the actual age within the margin of error, supposing that the test is sufficiently sensitive. Just like you can't really use a yardstick to measure the width of a proton or the distance to the moon, you have to use tests that are designed for what you're trying to measure. So if you use, say, potassium argon, which tends to return dates in the billions of years with error margins in the tens of millions, you're not going to get a calendar year out of that test for a rock that's a few decades old.
Well, they did it in 5 different ways, cut it every which way possible, and these radiometric dating analyses shows that this rock that we knew was only 10 years old came back 2.8 million, 1.7 million, 900,000 years old, 340,000 years old. It was only actually 30 years, this particular sample.
So let's talk about the guy who did this study, Steve Austin, the $6 million man.
Steve Austin, astronaut, a man barely alive. Gentlemen, we can rebuild him. We have the technology. We have the capability to make the world's first bionic man.
Wait, no, wrong Steve Austin. Let's talk about Stone Cold Steve Austin. Darn, still not the right one. Okay, I got it. Let's talk about creationist Dr. Steve Austin, a confirmed hack fraud. Now, you might think it's a bit of a stretch to call the good doctor a hack fraud, but in fact, this study that Dan Biddle is talking about is why I'm calling him a hack fraud. So Austin took 5 samples to be potassium-argon dated from the Mount St. Helens deposit. He took them to a lab that only had basic equipment for such dating, namely the Geochron laboratories in Cambridge, Massachusetts. They no longer do potassium-argon dating there, but at the time they did, they warned that they could not reliably date anything much younger than 2 million years. This means that essentially any date they gave that was 2 million years or under was essentially the same date and couldn't be distinguished from a date of 0 years. Interestingly enough, that's 4 out of the 5 dates. Let's go into why the dates are incorrect. With the relatively inexpensive machines that Cambridge was using, small amounts of argon remain in the test chambers because, being a heavy inert gas, it's not easy to get all of it out of the place it has settled into. Higher end machines can, but these could only partially evacuate the argon from the test chambers. Now, for rocks of over 2 million years old, this small argon signal from residual argon of other tests isn't a big deal, and will tend to get lost in the instrument error. However, for very young samples, this residual signal is essentially the only argon signal the machine is likely to pick up. As a result, the machine will always give results with significant age from a few 100,000 years to about 2 million years old, because it is physically incapable of doing otherwise. So Dr. Austin either knowingly submitted samples to a test he knows can't be run on them reliably, or he's so incompetent that he can't even figure out the problem. So yeah, like I said, he's a hack fraud. But then what about the 2.8 million year test date? Which, by the way, had an error margin of 600,000 years. That was a sample of pyroxenes, and in the original write-up about this little experiment, Austin et al. Have pictures of the pyroxenes under the microscope. And it has little granules that Austin says were not older material, but were simply materials of the same age. However, he does not really justify that statement, and other geologists note that they are consistent with what are called xenocrysts, which are small inclusions of significantly older crystal. Such contamination would give anomalously old readings. While Austin simply dismisses this possibility, real scientists have no such luxury. So essentially, in the one date that even could be valid, we have good reason to think that there is contamination from much older rock. Overall then, this study says more about Austin's honesty and ability to do science than it does about radiometric dating.
So all 5 studies shows that a 30-year-old rock goes back and it's hundreds and hundreds of thousands of years old.
Yep, just like if you were to try to measure a proton with a ruler marked in millimeters, you're probably going to get the wrong result. If you do use the wrong machine and techniques to date rock, you'll get the wrong result. I'm not sure if Dan thinks this is supposed to be some kind of revelation or what.
This happens all the time. I was in an online debate once with a geologist, and he was saying, Dr. Biddle, it's crazy you believe this fairy tale, stuff about Genesis and the genealogies, because we know radiometric dating is true. And I said, okay, that's great. I said, do you know of any studies of radiometric dating where they've taken the radiometric age of a rock into a lab and it validates to the known age of the rock?
Again, Dan prattles on for far too long. But let's see. He wants a radiometric study that confirms the historical age of a volcanic eruption. Okay, how about the 1997 paper, Argon Dating into the Historical Realm, Calibration Against Pliny the Younger, by P.R. Rene, W.D. Sharp, A.L. Dano, G. Orsi, and L. Civita, which got the age of the volcanic eruption correct with a margin of under a year, as compared to the historical events and dating provided by Pliny the Younger, who lost family in the eruption. I think that's pretty good, and exactly what the doctor asked for. As a result, I'm going to skip the rest of his rambling anecdote in which his debate partner says that he can't provide such a reference. I suspect this debate is fictional.
Okay, so my daughter was taking an advanced history class, and I was having fun looking through her book with her. And I said, look at this. This is very interesting. They have chronology of all these different events. Like they've got the life of this guy Buddha, 563 BCE, the invasion of India, 520. There's another date here that's 327 before Christ. And notice here on these dates of these very historical, validatable events, like the Kushan Empire and everything, they have date ranges for them, but the date ranges all end, and they have the hundreds placed down, the tens placed down, and the ones placed down. So they know for sure that this Mauryan dynasty went from 321 BC to 185 BC.
Except that they don't really. You see, this chart for babies doesn't give the uncertainty ranges of any of this. You see, in the ancient world, dates are hard to correlate and know for sure when compared to our modern calendar. For one thing, many societies didn't keep a count of years that just continuously ticked up until fairly recently. Instead, numbering years was based on how long their monarch had reigned up until that point. So if monarchs overlap or there is a civil war, dating by this method can become hard to disambiguate. Further, monarchs have been known to exaggerate the length of their reigns. Now, archaeology can help constrain dating estimates by giving independent methods for dating things. For example, if a coin says it was minted in the second year of the reign of Abu Ja'far Abdullah, the second Abbasid Caliph, we might be able to assign it to a date of 755, 756, or 757 based on our understanding of things like the fact that the Islamic calendar year is shorter than the solar year, and our historical records, and when this caliph reigned based on both the caliphate's internal records as well as the records of foreigners who had diplomatic, trade, or hostile interactions with the caliphate. Let's say it was found in a midden, which is just a fancy word for a trash dump of historical significance. Well, we can test organic material from that time, and we'll probably end up with a date that is in the mid-8th century, give or take a decade or so, which matches up reasonably well with our dating based on historical records. But as we go back farther and farther in time, records become more scarce, both because literacy was more scarce, and because as time goes, any given historical record has a greater and greater chance of being destroyed. So that the proportion of surviving historical records versus those that were ever created at a given time goes down as you look back in time. As a result, if you wanted to date a papyrus from the reign of Pharaoh Khufu, you will have much more ambiguity, because we're not looking at 1,400 years into the past, but more like 4,500 years into the past. Our records of that time are more fragmentary, and of necessity, our empirical dating techniques are less precise. All of this being said, our dating ranges will still tend to cluster around year numbers that are not round numbers for the whole historical period, because if your date is 2574 BC, with an error margin of 5 years, and you're making a chart for babies who aren't really equipped to take on board all the things like conflicts in calendar length, the regnal years, and the error margins of thermoluminescence and carbon dating, you're going to simplify things, and probably cut out the error bar. But on the other hand, if the date you have is 54,323 years, give or take 300 years, you might as well drop off the 23, because it's tiny compared to the size of your error bar. But that doesn't mean you don't have knowledge about when such events occurred. It's just that it's less precise than in the first case. Also, I'd like to point out that if you want to know the consensus for when a certain thing occurred, looking at a textbook for children is not where you go. History, archaeology, and paleoanthropology have peer-reviewed literature, which is where you get the actual real consensus views. And they'll include the uncertainty in the dates as well as how such dates were determined in the first place. So while I know that Biddle's audience is self-admittedly schoolchildren, he is attacking science but using non-peer-reviewed textbooks as his source for what science actually says. That's dishonest.
Now let's go to things of the distant past. Look at this. They have the era of Australopithecines, between about 1 and 4 million.
Dan here seems to imply that we have a margin of error on when Australopithecus lived of about plus or minus 1.5 million years. But really, what this says is that the genus Australopithecus existed for approximately 4 million years continuously.
They suddenly widen it way up. And then the era of Lucy, about 3.5 million years ago.
But Lucy is an Australopithecus, which is why her era overlaps with that given for Australopithecus. But being an individual as opposed to a genus, she only existed for at most a few decades, not 3 million years. So it's not that the wide range of dates for Australopithecus is a sign of uncertainty. It's a sign of the duration for which the genus to which Lucy belonged existed. Basically, Dan Biddle can't read a timeline made for babies.
Early experimentation with agriculture, they say, maybe 10,000 to 8,000 and 10,000 to 300. Look at all the zeros here.
Yep, dates from before historical records, that is dates from before the invention of writing, can't be cross-checked with written records. So all we have is various kinds of empirical dating, which can have fairly high margins of error. But also, he keeps implying that the date ranges are an indication of uncertainty. But all of the dates on this timeline have uncertainty, and the fact that it isn't given for the dates with single numbers means that these ranges aren't there to indicate uncertainty, but date ranges over which some event transpired. I mean, think about it. Did, quote, experimentation with agriculture happen only a single year and then humans had it figured out, at least locally? Of course not. Agriculture is a sophisticated technology that would take a long time to figure out. That's why it took thousands of years to have it be a reliable basis for civilization. And so, because this period lasted for a long time, date ranges are given. And as for the zeros, again, the book is for babies, so you gotta simplify things. But God forbid Dan ever actually look at things like the actual dating methods used to come up with these numbers. They don't return round numbers, they return something with error bars that contain round numbers. And for the sake of convenience, we give those round numbers to children.
So over here we know precise history, validatable, reliable history. Over here, big, long ranges.
Yep, because some things take a long time and we don't have it written down.
Because they're estimates, because they're based on theory and inference that we can't go back and test, because we can't go back that far. There's only 4,000 to 5,000 years of history.
Interestingly, yes, there is more than 5,000 years of recorded history, which means that both the Mesopotamian and Egyptian civilizations managed to get through the flood that wiped out all flesh. Weird that. But let's say we wanted to test when the first experiments with agriculture were being done by humans. First, we know we have reliable, but not always precise as we'd like, dating methods that don't require history. Well, what would we look for? Well, one thing would be pottery for storing grain long term, another would be the remains of crops that are significantly modified, and another would be the rise of permanent dwelling, because of necessity, as a culture becomes dependent on farming, they also must start staying put. No more nomadic hunter-gathering lifestyles when there are crops to sow. And hey, guess what? That's how archaeologists came up with these estimates. I would be curious to know from Mr. Biddle which part of this he thinks is invalid. With that though, I think we're going to leave Dan for now, as at this point he's going to do a deep dive on Australopithecus afarensis, or at least the Lucy specimen, and that deserves to have not too much of it shoved into this one episode, with the rest of it in another one. So for now, I'm the Dapper Dinosaur. Please don't forget to like this video and subscribe and turn on the bell notification so you're always notified when there's more Dapper Dinosaur content.